Okay. So concerning labs, right? So first, I have to say apologies because I accidentally put the wrong date for the due date. The due date is always the midnight of the next week, following week. So you had about 2 weeks to do this first lab report. So I can't. There is no more lateness for this first lab. If you didn't hand it in, then points will be deducted. I can't, give you another week or even another day. You had almost 2 weeks for this lab. So if it's late today, then it's late. I can't, I'm not gonna postpone the lab longer. So if you hand it in, points will be deducted because you had 2 weeks for this first lab. If it was 1 week, I'd understand, but this first lab, you had about 2 weeks to complete it. And some of you guys emailed me regarding uploading the wrong documents, right? So I have office hours. You can utilize. So the last 2 weeks I didn't have office hours. So you could have emailed me privately and we could have set up an office hours where I was able to help you. There was one of your students, I believe, emailed me not last week or maybe the week before, and we set up an office hour where I helped her, or not help, but we figured out how to do the lab. So if stuff like that comes up, please email me if you can't make it to office hours. Yes, Serena.
So I submitted it this morning because I saw that the due date was tonight. And am I going to get points off?
No, due date is still tonight. You don't get points off if you submit it early.
Oh, gotcha.
Right.
I thought that you meant that you put the wrong due date and the due date was actually last night at midnight.
No. I did say that. The due date I accidentally put for last night, but the due date is actually tonight.
Okay. So
what I was referring to is that you had 2 weeks to do the first lab report, right? So everyone had about 2 weeks to do a lab report. So if you're emailing me saying I didn't have time to do a lab report, that is not a good excuse because you had 2 weeks to do the first lab report, right? If you email me a medical exemption or a religious exemption, I would say okay. But if there's any other reason why you couldn't do the first lab report in 2 weeks, then it's not a valid reason for me to give you longer time to do a lab report. Okay. So
okay,
all labs will be due 1 week after the previous lab. But if you guys, so what I could make a deal with you guys is that what days do you guys have lecture? Tuesdays, and just 1 day a week?
Yeah, and then our recitation is split up, like some Tuesday class and then like a Friday class.
My lecture is on
Friday.
Monday.
I'm sorry, your lecture is?
On Monday.
On Monday. So some of it has lecture on Tuesdays and some people have lectures on Mondays, right? Am I understanding that correctly?
Yeah, I have Monday, Thursday.
Monday, Thursday, okay. And when do you guys, if you guys look at the syllabus, what days are your lecture exams? Mostly on Tuesdays?
Mine are on Fridays.
You're on Fridays, okay. And everyone else is on, since it's Tuesday, Thursday, Friday. Okay. All right, so yeah, so if the only thing I could make a deal with you guys, if you guys need extra time as a group, you guys can all email me, or even the week beforehand, if you guys let me know you guys have a specific exam on Tuesday night, then the best thing I could do is postpone your report until Wednesday night. That's the best thing I could do. If you guys let me know in advance that we all have, as a group, have an exam Tuesday night, best thing I could do is postpone it until Wednesday night. That's the most I can do for you guys, because it's already due midnight. So the best thing I can do is give you 1 more day so you guys don't have to rush and finish it. Okay. Lakshita, yes.
Hey, Professor. So
Hello.
I did the lab report this weekend, like on Saturday, Sunday. So I haven't
Say that again, please.
submitted. I did my lab report this past weekend, And
Okay.
I did not email you because of the weekend. And I was still working on it today. Like, I was completing it, like the last steps. And I realized that I was still having confusion with the experimental section since we did not perform any experiment, like, in the lab itself. So I just put how we went to the website and we got the boiling points and, we graphed everything. Is that
Oh, so
okay?
you're talking about the procedure, not the experimental. Experimental or the calculation results are both that you just showing the graph, the molecules, that's part of the calculation and experiment and the calculation. Are you experimental or are you talking about the procedure? Well, that's what you're referring to, right?
Yes, because when I go to the format, like on syllabus, it says there's heading, abstract, introduction, experimental, then data, and then calculations and results are separate.
Yes. So yeah, so that's fine. That's what you put, how you looked up the information, that's fine. Honestly, for this first lab report, I don't really look at procedures in general because I know what the procedure is. I'm not gonna take off any points just because you got the procedure wrong, or for any of the future labs. But everything else, I will look at, because the procedure, you guys should know the procedure, right? Because it's basics. So there's not really anything important that I will look at for the procedure with.
Okay, and is it okay if I ask you one more question? I'm so
Yeah, go
sorry.
ahead.
Okay, so for the discussion and conclusion, right? When I go to the discussion, as it explains there, it says, you have to tell whether your results are good or bad and give your explanation, right? That's okay. But then when I go to conclusion, it says summarize your final conclusion in your discussion section. So basically discussion and conclusion is same thing.
No, well, so what you're saying is that and just summarize everything you've done, because your discussion is a summary of your experiment, right? So basically everything you've done in the experiment and you're talking about the data. So that's what the discussion is. Conclusion is anything you found useful or anything that made this experiment, that you learned from this experiment or something that you got out of the experiment. So just like a little summary of the whole experiment in general. You don't have to put any information, but just in general, what you learned from the experiment. That's what the conclusion is. The discussion is all the data you've gotten from the experiment and putting it basically in words. And also in some of the lab reports, you have questions. And so you have to answer those questions in your discussion section.
Okay, so can we basically just relate the conclusion section to our introduction? Like say how we explain everything in the introduction, as you said, you have to talk about the intermolecular forces and stuff. And in conclusion, can we relate it back to that is why, this is different?
No. Your conclusion is basically a summary of your discussion. So you don't have to repeat everything you've done in your introduction or anything, right? So so let's say for the lab that's due tonight, right? You guys all the boiling points. So you can say in conclusion, you have learned that molecules that have this have lower boiling point. Molecules who have this have higher boiling points. I've learned how to, use Excel or, all that stuff, just in summarize. You don't have to put any, it shouldn't be more than 4 or 5 sentences, your conclusion.
Okay, thank you so much, sir.
No problem. Any other questions? No? Okay, also one more thing.
Professor?
Yes.
Yeah, I was like, how many pages do you need the lab report to be? 2 pages is good?
Oh, there is no minimum or maximum. Just you don't have to write too much, just get straight to the point. There is no minimum or maximum for the lab manual, for the report, sorry.
All right, thank
So
you.
just however pages you need. I can't put a number on it. Just whatever you think is sufficient. Also, another thing is that coming to lab is mandatory. Okay, so there's about 23 students in this class, and there's only 19 students here. right? And so far, nobody emailed me beforehand about not missing this lab except for this one student. So you must come to lab, even unless it's a religiously exempt lab. Other than that, lab is mandatory. So for students who are not coming to lab and just go watch the videos online, let them know that points will be deducted for not coming to lab. They will lose a significant amount of points for not coming to lab. So lab is important to attend to. Just because it's going to be recorded and posted on Blackboard, that doesn't give you the right to leave lab, because there'll be I don't want to go over everything in that I've already said in the video, and then people emailing me again asking what did I say. All right, because basically 100% of your grade is from your lab report, because I can't see you physically. So the only other thing that could help you increase your grade besides your lab report is participating. So if you're not in the call, then you're not participating, right? So I need everybody to at least participate sometimes here and there. If you're not participating, then I know, it's not, you guys either not understanding, or you guys aren't really paying attention, or you guys are probably watching Netflix or sleeping or something, right? If you're not participating. So please participate. It will only help boost your grade. It won't lower it. It will only help you boost it. Okay? All right. So any other questions? And when I mean participate, if you're shy to talk, that's fine. If you're putting in the group chat, that's fine. Just, I just want to see you guys be active. All right? Sounds good with everybody? Can I get a yes or a no?
Yes.
Yes, Professor.
All right, good. Okay.
Yes.
So, perfect. Yes. Everybody in agreement. So, just want to tell you again, there's 23 students in my class, in this lab class. At this moment, 18 of you are here. So there's about 7 missing, right? So if you know those 7, hopefully they will watch this recording when they see it, that they will be, points will be deducted from their lab manual. So every day I'll take a attendance randomly to see who's there at that time. And if you're there, then you're good. If you're not, then points will be deducted. Okay?
Professor,
Yes.
this one student, Brooke Rahman.
Yeah,
Okay.
Brooke emailed me, so it's fine.
Okay.
Okay. All right. So I guess if no other question, we'll start today's lecture. Okay. I mean, not lecture, but lab. Okay. All right. So today's lab so I uploaded maybe like 10-20 minutes before the lab started a document that you guys will need for this to do this lab at home. Okay. If you guys have a chance, do you guys mind opening it up real quick? It should be on Blackboard. Go to content, and on the content, you'll see lab 2 info. Okay. Oh, well, no, this is just names, random names. It doesn't have it doesn't have anyone's particular name. It's just sets of information that you guys will use. Okay. It doesn't have anybody's particular name. All right. So does everybody see it? Malika is able to see it. Anybody else able to see it? Just let me know if you guys can or cannot. All right, perfect, cool. If you should open up the data just so you can see what the data is. Should we open the PDF of the lab 2? Yeah, you could open it. We're gonna go over it. Can you guys see my screen? Just say yes or no.
No.
No? Okay, let's start again. How about now?
Yeah.
Can you guys see it? Yes?
Yes.
Professor,
Yes, go ahead.
I don't see my name on the chart thing.
Oh, well, you're not supposed to see your name, okay?
Oh,
These are just names of students that did it previously, and we use their data table. So
oh,
nobody's specific name is here. I'll assign you guys a student's data, and you guys will use that for your lab experimentation. Okay? Sounds good.
Wait, I don't see this. What's
Yeah.
it under?
So if you go here, if you go to content,
Oh, sorry, I opened Beer's Law by accident.
okay. If you go to content, you're gonna see something that says lab 2 info, and
Okay.
if you press on that, you should get the data table, right? Yes. And everybody should just see some names that's coming up, right?
yes.
All right, perfect. Okay, so today's lab is iron content of a table of a tablet by redox titration. So we actually did this lab experiment last semester, and the students who actually did it real well. If you guys know some of your upperclassmen, they will tell you that this is probably one of the most better experiments to do because it's how do I say it? It's very meticulous. So if you actually do the experiment, you will get a pinkish purple color. So students who are able to get the exact lightest pink color and keep it stable do it really correctly. And students who get a really dark color, it's not done correctly because you over reduced your experiment, over reduce the compound, so it doesn't go exactly planned, but it's a fun experiment if you guys did it in person. Has anyone ever seen a redox reaction done? A titration reaction? Sorry, I can't see your chat because when I'm sharing, so if anyone could just say yes or no or yes, no, okay?
No, I haven't.
Okay, so I'll show you guys a real quick demo. Okay.
My class did last semester on campus.
Can you guys see the whiteboard?
Yes.
Okay, cool. So what happens is this. So you have this little thing right here, right? You have your titration, a little funnel, right? A little stopcock, and then you have something that pours, right? So you usually fit the KMNO, right? KMNO4, right? Over here, and then you have your iron tablet here, right? And it's in solution, right? Iron tablet. So little by little, drop by drop, you put it, right? And then you swirl it. As you swirl it, right, the color changes. At one point, the color stops changing and you get a pink hue, a very light pink hue. Light pink, right? And once it has the faintest light hue, permanent light hue, then you know all your iron tablets have become iron, right? So that's how you know it has become the it's become oxidized. It has lost. It has lost its things, okay? It has become reduced. So that's how you know that this experiment, that you got the correct moles of compounds, or the correct moles of KMNO4 reacted with the right moles of iron to get for all the iron to be oxidized. Okay. So this experiment actually pretty fun if you do it in person. Last semester, one student, it broke this part here, actually broke off, and it just splattered, but nothing happened because it's not permanent because you have the lab coat on, but it's a fun experiment. Okay. Any questions? No questions? All right. Perfect. Okay. So in this reaction, right, what are we doing? So we're taking so what we're doing is we're taking manganese, right, oxide, and we are reacting it with iron, and we're getting this balance equation on the bottom right here. So download this. One second. Let's see if I could. This thing doesn't right. Just now let me write. Okay, that's fine. So let's do it this way. So the reaction we're doing is so half reaction. So it's MnO4 minus plus 8 hydrogens plus 5 iron. Then you get MnO2 minus, so 2 plus. 2 plus 4 H2, right? So this is your reduction. So reduction means what? Is it gaining electrons or losing electrons?
Gaining.
They're gaining.
Yes. Yeah, so what's gaining the electrons? From these atoms, right? This, and this. Which one is gaining electrons?
Is it manganese?
Yes, manganese is gaining electrons, correct. Because originally it had a -4, right? Minus charge, right? And now it's a +2 charge. So it's gaining electrons. Sorry. Ooh, no. It's not manganese, sorry. This is a half reactant, sorry. The overall reaction, we look at what's gaining an electron. In the half reaction, we look at both together. So half reaction reduction and oxidation is Fe 2 plus goes to Fe plus. So which one is gaining? Manganese is gaining, you're right. So which one is losing? So oxidation.
Iron?
Yes, so oxidation means something is losing electron, right? So Fe2 plus is becoming Fe3 plus, and it's losing electrons. So that means manganese has to be what? You guys said it.
Oxidizing agent?
No, but manganese is gaining electrons, right?
Okay.
Because, right? Because if iron is losing electrons, manganese is gaining electrons. Okay?
So is the reducing agent?
Yes, so if something being oxidized, the agent it is reducing agent. So if this is being oxidized, the iron, it is the reducing agent, right? If something is being reduced, it is the, go ahead, somebody. Which one of
Oxidizing.
the,
Oxidizing agent.
yes,
Oxidizing.
perfect, oxidizing agent. So the oxidizing agent is MnO4, right? And the reducing agent is iron 2 plus. Okay? Any questions? Before I erase this, any questions? No? Okay. So now we look at the balance equation, right? Is MnO4 plus 8 hydrogens plus 4 iron. Sorry, 5 iron. Two plus goes to 2 plus 1 plus 4 molecules and 5 iron. Right? Okay, so if you look at this is what? This one is being what? Is it the oxidizing agent or reducing agent?
Repeat that, sorry.
The MnO4, is it oxidizing or reducing?
Reducing?
Yes. No, MnO4, if this is being reduced,
It's oxidizing.
yes, oxidizing. Is our oxidizing agent? Is our reducing agent? Sorry. The iron is our reducing agent. Right? Because the iron is being oxidized because it's losing an electron from 2 plus and is becoming 3 plus, right? And this one is gaining electrons, right? And becoming 2 plus. Okay? All right. So in this, any questions? No?
No.
Okay, so this lab is pretty simple. Okay, so, right. So now if you look at the lab, so if you look at the lab, right, what you're doing, this is basically telling you, what color you're supposed to get. This is your procedure. We don't really care about that. And obtainable. You guys can read this procedure, now calculation. So we want to know how many grams are in our content, right? What is the equation that relates molarity? Does anyone know the molarity equation?
Is it the mole?
Can't hear somebody.
Moles of solute over liters of the solution.
Yes. So moles over
Liters.
Liters.
no. No. You said, what did you say? I can't hear you correctly. Anybody there?
Yeah, is it the moles of the solute over the liters?
Yes, moles over liters, yes. So if you guys look back at the data sheet, right? You have two volumes. So your initial and your final. Your initial is how much KMNO4 you started with, right? And your final volume is how much you added to get that pink hue or whatever color the hue was, right? So then you would calculate the moles of how much Tritrent you added, right? So that is the moles that will convert to your iron to see how many grams of iron you got. Okay. So let's take an example, right? Let's use Zhang Liu, right? Zhang Liu.
Professor, you there?
Go ahead.
Oh, I thought you froze.
Oh no, did I look frozen? Okay, so let's look at Zhang Liu's information, right? Right. So Zhang Liu had the two trials, right? Trial 1. Trial 2, right? So in trial 1, initial was equals 1.9, right? And final was 33.70. 33.70. And for trial 2, initial was 13.14. And this is final was 43.75. And this is in what? Milliliters or liters, guys? This is in milliliters. Okay. So when you do your calculation, what do you have to convert this to?
Liters.
Liters. So you would just go back 1, 2, 3, and that's how much liters you have. So 0, 3, 3, 7, 0 liters, right? Same thing with this. Right? 1, 2, 3. It's 0.04375 liters. So don't forget that. That's very important when you guys are doing your calculation to get the units correctly. Okay. All right. So now let's calculate. So let's see how much Tritrent he used. So if we take experiment 1, right? I'll erase some of this. Right. So let's keep it in milliliters for now, okay? And then we'll change it back. So it's 33.7 minus 1.9, right? 33.7 minus 1.9. So he used 31.8 milliliters, right? So now what is the concentration of the KMNO4? It's written down there, right? KMNO4 has a concentration of 0.007453 molarity, right? So you take 0.00743, right? And then you get the moles of how many KMNO4 you use. So it's 0.318 liters. And that's how many moles of KMNO4 you use, right?
Are we supposed to be writing this stuff down?
I mean, that's up to you because I'm giving you how to do the lab report, basically. So if you want to do a lab report, this is exactly what you have to do. That's a good question. Who asked?
Me,
And who is me?
Matthew.
All right. Yep. Matthew's right, guys. So if you guys have any questions about what I've done so far, this is exactly what you have to show me in your own report. So ask now, please.
Could you repeat that again, please?
Okay. One at a time. Go ahead.
Sorry, do you mind going over it again, please, slowly?
Okay. Let's go one more time. Does everybody see the data table, right?
Yeah.
Yes. You see the data table, right? So the data table gives you two trials, right? So I'm, for example, taking, Zhang Liu, right? I'm taking Zhang Liu's information. Zhang Liu did two trials. His initial volume was 1.9 milliliters, and then his final volume was 33.75 milliliters. So that's how much. So that's how much he added of KMNO4 to get exactly oxidize Fe2+ to Fe3+. So this is how much solvent he used, right? Okay, let me start all this over again. Okay, so his trial one, he used, initial was 1.9, right? Final was 33.75, right? Milliliters, right? So I want to know exactly how much KMNO4 he added to oxidize all of the to oxidize all of the Fe2+ to Fe3+, right? So to find out exactly what the volume was, I just subtract 33.75 minus 1.9, and what do I get? 33.75 minus 1.9, I get 31.85 milliliters, right? That's how much KMNO4 minus he used to oxidize iron 2+ to iron 3+, right? Everybody's good with that, right? Any questions about what so far on that?
I was wondering, why would you subtract?
So because we initially already had, so when you actually do the experiment, right, you're left with some KMNO4 left in the beaker. So instead of throwing that away, we just add more and we include that in our calculations, okay?
Okay.
All right, so this initial is because this was actually done by students and we gathered the information from the students. And that student, Zhang Liu, originally when he did his first titration, he added 1.9 milliliters, and then he added some more all the way to the top, and then his final volume after he added everything was 33.75. And to find out exactly how much KMNO4 he used, we just subtract the two. Right? Any questions? Yes, no? Everybody, anyone there?
No, we're good.
Okay,
Where does
perfect.
where does the iron come into all of this?
Oh, where does iron? Okay, so okay, let's go back. So remember the first thing I showed you guys was how the experiment works? Was this little drawing? Do you remember that, Matthew?
Yes.
Matthew, do you? Yes, no? If you don't, it's fine. I could
Wait,
go
wait,
over
wait.
you.
Actually, no, I don't remember.
Okay, that's fine, no problem. Okay. All right. So when we actually do this experiment, we crush up some iron tablets. When you go to a pharmaceutical company, okay, does anybody eat Tylenol? Yes, no?
Yes.
What does Tylenol say? How many milligrams are in per capsule? Can anybody?
325.
Okay, 325, right? So let's say when babies are born, right? What supplements are they given? Iron supplements, right? Why are they given iron supplements? Does anybody know?
Because they have low iron.
No.
Okay.
For the
Good try, but
bones
it's
to
not.
develop?
No, it's not low iron.
Doesn't it
For
have to
the
do with
bones to
something where
develop?
they're like, oh, sorry, what were you saying?
Like to develop better bones or like stronger bones. I don't know.
Our body has what? Blood cells. What is the main component in blood cells? What helps facilitate?
Isn't it like
Hemoglobin?
it's
Yes.
like
What is the
iron-
centerpiece of hemoglobin?
Can you repeat that, please?
Somebody says
Plasma?
no.
Plasma? No, I don't
No.
even know.
No. Okay. I'm not. All right. Okay, guys. All right. So our body has red blood cells. Let's say this is a red blood cell, right? We're going a little bit off topic, but might as well teach you guys now. Red blood cells, right? Our red blood cells, right, have a protein called hemoglobin, right? So this is the protein hemoglobin. It's a four-member capsule, not drawn really well, but this is the hemoglobin, right? This is the protein, right? The centerpiece of this protein is iron.
Isn't that what makes the blood red?
No, what makes blood red is myoglobin.
Oh, okay.
Well, what makes blood red, it's red blood cells, I believe. I don't know exactly what makes blood red, but there's two different proteins, hemoglobin and myoglobin. Muscles are, when you cut into an animal, muscles bleed blood because of the myoglobin in there. Myoglobin has that red distinction. But blood itself, I don't know if what causes blood to be red, but it probably is the same reason. Okay. But let's go back to this. So our body has iron, right? We're going a little bit off topic, but we use iron. So why do baby take iron? Because it helps them facilitate oxygen carriers. Iron, or just this whole species, hemoglobin, carries oxygen, right? So some babies are given iron tablets to help facilitate oxygen because our brain needs oxygen. Does anybody know for what? Why does every function in our body need oxygen? Especially the brain.
Starts to
Aerob-
die without it.
Yes, but what is the main purpose of oxygen in our body? Oxygen only has one main purpose.
Aerobic respiration, something like that. Aerobic.
Very close. It's very close. It's very close, but oxygen has one purpose, and it is the last acceptor in our what do you call it? I forgot the name of it. Man. And what is that? What is the thing that mitochondria does all the time?
It's the powerhouse of the cell.
ATP?
It generates ATP, right? The last purpose of oxygen is that it generates ATP, right? It gives you energy, right? Sorry, glycolysis, yes. Glycolysis. The last step of glycolysis, right, is to create ATP, to create energy, right? To make ATP, we need oxygen as the last acceptor of electrons, because oxygen is a very good acceptor of electrons. If we're unable to donate these electrons to oxygen, no ATP will be created. And without ATP, nothing in your body works, especially your brain. Your brain is the biggest muscle in your body. It needs the most amount of ATP. So if your body cannot generate ATP or have oxygen facilitate to the brain, then it doesn't work. So that's why a lot of babies are given iron supplements to help facilitate oxygen to the brain and the rest of the body, right? So that's the main purpose of iron biologically. Now, let's say you're a chemist and you want to know exactly if the iron tablet you're buying from the chemical store is saying that it has 500 milligrams of iron. How would you know that? That you're not getting duped by the pharmaceutical industry, that the tablet you bought doesn't have 500 milligrams of iron. How would you know that? Any guesses? You're just gonna take their word for it, I guess?
Does it have something to do with the titration?
Exactly, titration. That's exactly what we're doing. To find out if you guys are not getting duped by the pharmaceutical industry, we do titration. And we know that iron 2+ can become iron 3+, right? So by doing titration, so let me erase all this because we don't really need all this. And I'll go back to explaining why we're doing iron, because we want to know how much iron is in that tablet that we've just bought from the pharmaceutical company. Right? So now we want to know exactly how much, right? So we buy this iron, right? We crush up the iron, we dissolve it, we do everything, and now we have iron in here, right? A solution of iron, right? And we want to know exactly how much grams or milligrams are in that iron tablet. So we do titration. KMNO4, as we said, is a good oxidizing agent, right? So we are oxidizing the iron 2+ to iron 3+, and KMNO4 is getting reduced, right? So that way, when we do this reaction, we get a pink hue, and this pink, and the lightest pink hue tells us that all our iron 2+ has become iron 3+. And once we do this experiment, by guessing how much milliliters we added of KMNO4, we could calculate how much grams of iron we have. Okay, so that's the reason why we're having iron, Matthew. Is that clear or no?
I understand it better. So like, what's the reaction again? Like, it's iron 2+ is reacting with which substance?
With the KMNO4. So let's go back to the balance. So do you have the lab? Nope. Do you have the manual open, Matthew?
Yes.
So look at the reaction, the balance reaction.
I don't. Wait.
Actually, give me 1 second.
I just have the lab info. Sorry, open.
Okay, hold on 1 second. Let's go back to this, right? You see this reaction that says balance equation?
Which lab is this? Is this
the iron Fe iron tablet lab?
Oh yes, I see it.
It's confusing because Beer's Law is listed as lab 2.
It is?
Yeah.
Really? Am I doing the wrong lab?
Yes.
Yeah, under
Yes.
lab.
Let me check. Or do I have the old manual from last? I'm praying I don't have the old manual. And again, we are doing it wrong. Hopefully we're not doing it. Let me see. Why do they keep changing this? No. If you see week 2, right? It says check-in, safety review, iron content of a tablet by redox titration. Right? Week number 2, right? First week was exploring boiling points. And week 2 is check-in, but we're not doing check-in because we're virtual. And then it says iron content of a tablet by redox titration.
Not on the syllabus. When we go to lab
Yeah,
manual.
the actual lab manual.
Oh,
So-
no. You have to look at the syllabus. Why
No,
are
I
you guys
know,
looking at?
but I think we were just opening what was right under boiling points.
Oh, what? No. Open the. No, come on, guys. Matthew, are you?
Yes, I have the lab open. I have the
Okay.
lab.
Anybody else confused about what lab we're doing? Please, I just spent an hour explaining this, and you guys are just sitting there. Oh my! Didn't we do this last time? Didn't this happen last time too?
But on the syllabus, it says iron content. So we're doing iron content, correct?
Yeah, that's what I'm doing today, right?
Yeah.
That's what everybody's following.
Yeah, it's on the syllabus.
Yeah.
Okay, perfect. All right, so we're now all on the same page.
Yes.
All right, perfect. Okay. So Matthew, have you found the correct lab?
Yes, I can see the equation now, so I know what's
Okay.
I know what's going
Yeah.
on.
All right. So let's go back. So the equation is MnO4, KMnO4, reacting with 5 moles of iron 2 plus, and the manganese, right, is being reduced to manganese 2 plus, and the iron is being oxidized to Fe3 plus. Okay. And the half reaction is just showing you what reduction is occurring and what oxidation is occurring. So our MnO4 is the reducing agent. Sorry, it's the oxidizing agent because it's being reduced. And our iron Fe2 plus is the reducing agent because it's being oxidized. Hold on one second, guys. Okay, anything else?
Nope.
Okay, perfect. Okay. All right, going back. So, give me one second, sorry. My board. Okay, so let me go back to this. So you guys know so far what we've done, right? So trial 1, right? Trial 1 is initial was okay, so trial 1 is, let's go back to the data. One second, where's the data there? Okay, so if you look at trial 1, he had 1.9 and final was 33.85 milliliters, right? And the molarity of KMnO4 is given on the table is 0.00745 molar, right? So when we take the difference, we get 31.33. is 31.95, right? So that's how much milliliters of KMNO4 he added to reduce, to oxidize iron 2+ to iron 3+. Everybody okay with that?
Yes.
Sorry, where did you get 1.9 and 33.85?
Oh, that's from the data sheet I gave you. If you look at Zhang Liu, that's the first trial he did, okay? You see that? Yes?
Oh, that's 33.75, I think.
Oh, 75, sorry.
Yeah. Oh, okay. I get it.
Okay, so this is the final volume he has of the KMNO4, right? So now we want to turn this to moles, right? So molarity is 0.007453 equals moles per liter. So it's 0.03185 liters. We do the calculation and we get moles equals what? So it's 0.007453 times 0.03185. We get 0.00023738 moles, right? Everybody knows how I did that, right?
Yeah.
Cool. Now, how do you calculate the grams that we used? So how do you
put it
calculate
over
how
the
many
molar
grams?
mass?
I'm sorry?
You put it over the molar mass?
You multiply by the molar mass. So what is the molar mass of iron? Can anybody look it up real quick?
Uh, 55.8.
I'm sorry?
55.8.
Yes, so the molar weight is 55.8 grams per mole of iron, right? So now what do? So you multiply, right? So I'm gonna delete some of this. Delete all this. So now you multiply 55.8 grams per mole times the mole, which is 0.00023738, and you get what? So how many grams is in that tablet that we did? Is 0.01326 grams of iron. It's in that one tablet. Or you could say 13 milligrams. Okay, so that's how you would do this experiment with the data you have. Okay. Let me just double check. 0.00. Let me just double check. Yes. No, it's 0.0002. Yeah. Right, because you would multiply this, right? You have 3 zeros here. 1, 2, 3. So your answer should have 3 zeros. 1, 2, 3. Okay, so this is exactly what you guys will have to do for your data sheet you get. So there's 2 trials, so you have to show this twice. Okay, and then that's it. That's what you have to do for the lab. Any questions? And then you also have 2 questions you have to answer. So just go ahead.
Sorry. So we basically found the moles of KMNO4 then?
Yes.
Right now, whatever. Okay.
Yeah. you find the moles of KMnO4, right? And you multiply that by first you find the moles of KMnO4, and then you multiply that by the grams. And then also sorry, I forgot. It's 5, right? So the final product is 5. So you have to multiply this, right, by 5, because it's 5 moles, right? So that's how many grams of product you get.
Wait, so you
So-
find the moles and then you multiply by 5?
So you find the grams first, right? Because it's after you find the grams, you multiply that by 5. Or you could find the moles and multiply that by 5, and then you still get the same answer. Okay? Because it's 5 moles that are reacting. Right? So maybe you guys are confused, right? So you guys know how I got up to here, right? Up to this, right? How I found 0.000237
Yeah.
Yeah.
Okay, perfect. All right. So our moles was 0.000237, right? If you guys look at the balance equations, right? If you look at the balance equation, it's MnO4 minus plus 8 hydrogens plus 5 iron 2 plus goes to Mn 2 plus 4 H2O plus 5 moles of iron, right? So this, right, when you do it, you have to multiply your moles, right? This moles by 5. So it's 5 times 0.000237 right? And then once you get this, you multiply that by the molecular weight of, so it's 5 times 0.000237. You get 0.00142268, and you multiply that by the molecular weight of iron, and that's how many grams you get, times 55.8, and you get 79.6 milligrams, or 0.0796 grams, right? You guys understand that?
Yeah.
Yes.
So the reason why we multiplied the moles by 5, because in our balanced equation, there is 5, right? If it was a 1, then we didn't have to. But since there is a 5, we have to multiply it by 5 because it's 5 moles. Okay, so, and then once you get that, you do have to do it twice because there's 2 trials. So then I'll do the same calculation for the second trial of Zhang Liu. All right, so that's basically what you have to do. So when you do this lab report, just make sure you have show exactly the calculation. So the calculation, you could either do it through Word, however you want to do it, or you could just do it on paper, take a picture, and put it in your lab manual. Not lab manual, sorry, your lab report. So either one is fine for me, as long as I could see the calculations clearly.
What does it say on the top by 0.002378 on the left?
Oh, that's moles, sorry.
Oh, okay. Professor?
Yeah.
I'm just trying to understand. So you got, for molarity, you got 0.007453, right? And for volume, you
Wait,
got
hold on.
0.
slow down, would you? So the molarity was from the beginning you're talking about?
Yes, please.
Okay, so let's do it again.
I'm sorry, I'm just.
So everyone has the other PDF open that I posted, right? Everyone can see that PDF? All right. So if you look underneath it, you see something that says molarity of KMNO4. And that molarity is 0.007453, right? Everybody can see that?
Yes.
Right? KMNO4 minus equals 0.007453. This is our concentration, right? Concentration is based on molarity. So this is the concentration of KMNO4. So in trial 1, right, we find out that the amount of KMNO4 Zhang Liu added was 31 point, was it 85 0.85 milliliters, right? You okay with that?
Yes.
So now we want to know how many moles of KMNO4 actually was used. How do we do that? We use a molarity equation. Molarity equals moles over liter, right? So we know the molarity of KMNO4, which is 0.007453. We know the liters because that's how much was given to us by Zhang Liu, which was 31 in liters, has to be 0.3185 liters, right? And now we have to find the moles. How do you find the moles? We just multiply. And when you multiply, what do you get? Moles equals 0.00022374, right? That's how we found the moles.
Right.
Okay, so now we want to find, exactly how much, what do you call it? How much grams of iron was used, right? Now, if you look in the lab manual, we see the balance equation, right? So the balance equation is we get 5 moles of Fe3+, right? So we want to find how many grams. So how do we find the grams? Right? So we multiply the moles we used, the moles we got, because this is how much moles it reacts with the iron, right? So we use this, we multiply it by 5, right? And we get what? 0.0002375 times 5. 0.0002375 times 5.
0.01187.
Yeah, so we get 0.001. Oh, why do we get it? Why do we get in different numbers this time? Did I get the wrong?
Yeah,
Oh,
exactly. That's
thing?
what I was,
I've been my
trying
bad.
to understand.
Say that again. Oh, why did I get a different number this time?
Yeah, exactly. I was calculating and I see it's different, so that's why I was trying to understand.
7453 times 0.03185. Sorry, it's 0.23738. That's whatever, 0.2374, whatever. Oh, sorry, I guess I did the wrong calculation. You see, 2375 times 5, right? So this is the number. Sorry from last time. So this is the numbers of moles we get, right? Sorry, guys. So 0.0011875 is how much moles we would get, and to get the grams, multiply this, by 55.8, because that's the molecular weight times 55.8, and we get 66 point, let's say rounded, 3 milligrams, or 0.0662 0.3 grams. Okay, sorry, that's my fault. Why'd I get it wrong?
Can you scroll down? I can't see the work.
I'm sorry?
Can you scroll down the whiteboard? Can't see the
Can
work.
you see it now?
No.
What are you trying to see? Like right here?
I can't see your mouse. Can you move the mouse? Because I only see the number that you boxed times 5. Then under that, it's kind of
Oh,
halfway.
you can't see underneath that?
Yeah, I can't see underneath that.
So I'll just move it. I'll move everything up.
Okay.
So moles equals 0.00. Let's round it, right? 2. Let's round it to 2 is 237, right? So let's say 24, okay? Let's round it, all right? Round it. So then we get 0.0024 times 5 equals 0.24. Sorry, it's supposed to be one more 0 here. 0.24. 24 times 5 is 0.0012, right? And then once you have this, right, you multiply this by 55.8, and you get rounded, you get 66 point, let's say rounded to 67, okay? 67 milligrams, or you could keep it in grams, which is 0.067 grams. Okay? Everyone good with that?
Wait, why did you multiply by 55.8 again?
Because we want to find how many grams, right? So this is in moles, right? And 55.8 is the molecular weight of iron. So, hold on, you guys didn't learn this in general chemistry? You guys should know how to go from moles to grams and grams to moles. Right? It's the same thing. There's nothing different. Same thing. To find the yeah, so the same thing.
Oh,
So this is so we want to know how many grams there is, right? Of iron. So we multiply it by the molecular weight, which is 55.8.
that's the molar mass, 55.8,
Yeah.
right? Oh, okay.
Yep. And then that's how much iron is in that tablet that we oxidized. Any other questions, or everybody okay with this?
I'm good with it.
Everybody okay?
Yeah.
All right, so, and then you would do this for trial 2. So let's do trial 2. I'll show you guys how, so I'll do trial 2 for you guys. So you gotta do 2 hours. So trial 2, I'll try to keep it neat. Trial 2, right? So Zhang used for initial, he used, sorry. For initial, he used what? 13.4.
14 milliliters.
13.14 milliliters. And final was 43.75. Right? So we subtract this, right? And we get how many KMnO4 milliliters he used. So 43.75 minus 13.14, we get 30.61 milliliters, right? So then we want to find how many moles is that? KMnO4 molarity is 0.0074. 5. 0.007453. And so equation for molarity is moles per liter. Right, so then it's 0.007453 equals moles per 0.03061 milliliters. So moles equals equals 0.0022814, right? And then to find, so then moles times 5, because it's 5 iron tablets. So it's 0.00022814 times 5. Oh, 0.00114 moles. And then to find grams is molecular weight times moles. So grams, molecular weight is 55.8 times 0.00114. We get 0.063, just round it, 64 grams, or 64 milligrams. So 64 milligrams of iron. 3 plus is in that tablet. Okay, so that's everything you have to do for your lab. And then of course in the discussion you would include the answers and everything else, the calculations. All right, so this is all you have to do for this lab. There's a very short lab, easy lab.
Professor,
Yes.
is there a significant figure? Like, do you want the answers in any
No, it's fine. You
specific
don't have to
significant-
really, you could just round it to like how I rounded to 64, that's fine. I'm significant figures I'm not worried about.
And also you were saying something about discussion. I think you cut out.
Oh, and yeah, for discussion, you could just say if in discussion, you could just talk about oxidizing agents, reducing agents, and also include the answers to the questions in, because there's 2 questions you have to answer, just include that in your discussion too, okay?
Got it. Thank you.
Any other questions? All right, so wait 1 second. So I have to give you guys what data table you guys will use for the lab manual, okay? So give me 1 second, guys. Okay, so just answer me when you hear your name and that you know the data table you're gonna use, okay? Just say yes or something. Okay, Eliza, you will use Ada's data table, okay?
Can you repeat that? Sorry.
So do you see the data table right now, Eliza?
No.
Wait, no. Okay. You see it now?
Yeah.
Okay. So you will use Ada's data table, okay?
Okay.
Because I can't really see who's texting when I'm sharing my screen. Give me 1 second. All right, sorry guys. So Ashley, you will use Bali, okay?
Okay.
Brooke, you will use Katagua.
Thank you.
No problem. Christine, you will use choice. I don't know how to spell it, but Chorzipa, okay?
Sure. The one
Yes.
that it's like,
It's her last name is
Aldona.
Yes.
Aldana. Okay, thank
Yep.
you.
No problem. Okay. Christine. Cindy, you will use Cho.
Christopher Cho?
Yes. Christopher Cho, yes.
Got it. Thank you.
No problem. Cynthia, you'll use Chizzy.
Okay, thank you.
No problem. Jasmine, you'll use Jagoy.
I'm which one?
Jagoy Emily.
Okay.
Jason, you'll use Gao. Andy. Did Jason answer? Okay, cool. Jason. Christina is Christina, you'll use Jean, okay?
Got it, thanks.
Yep. Lakshita, you'll use Core.
Or Maninder?
Yes.
Okay, thank you.
Layla, you'll use Mansuto.
Monsuto, got it. Thank you.
Yep. Malika, you'll use Paparosopolos Andres, okay?
Okay, thank you.
Yep. You guys know what I'm saying, right? Before you guys go on and say you don't know what I'm saying. You guys know what I'm referring to about the data sheet, right?
Yeah, we do.
Matthew, you'll use Rivera. Matthew?
Yeah, I was just looking at it. Yeah, yes, I
Okay.
see it.
Monia, you'll use Shaharin.
Okay, got it.
Samantha, you'll use Sean.
Okay, thank you.
Sejla, you'll use Sharma.
Thank you.
Serena, you'll use Sile.
I'm sorry, which one?
Sile, Sial. Sile,
thank you.
Samantha. Okay. Shira, you will use Tenant.
Okay. Thanks.
Yep, Tenant. Suleiman, you will use Tisin.
Tzin.
Yes. Tesin. Okay.
Got it.
And Zuaira, you'll use Theodore.
Kyra Theodore.
Yes.
Okay.
Okay. So everyone has the data sheet that I used from the corresponding students. Okay. All right. So if you have no more questions, then you guys are free to go.
Thank you.
Thank you. Have a good night.
You too.
Thank you so much.
Thank
Yep.
you, Professor. Have a good night.
No problem. You too. Have a good night, guys.
Can I see the data sheet one more time?
The data sheet.
Yeah.
Layla, did you leave?
No, I'm still here.
Okay. Give me 1 second because I didn't get to see your text. Give me 1 second, okay?
Sure, sure.
There you go.
I got it, thanks.
Okay. All right. I'm sorry, Layla. What were you saying? I didn't get to read it.
Sorry, hold on. So I tried to email you a couple of times yesterday because I switched lab sections over. I got permission from the chem department, and
Okay.
I was watching the first lab, and of course I wasn't assigned a data set, but I was trying to reach out to you to see.
Yeah, I didn't get any emails from you.
I sent 3, literally.
3?
Yeah,
I
3
have
of
not.
them.
What email did you use?
I used both of them that were available. Give me one moment. I'm gonna tell you.
I only have 1 email. What was there's 2 emails? They probably gave you the wrong email.
Yeah, I went by the directory because
There's a
hold on.
directory?
There's a directory on the student side.
Okay.
One moment. Yeah, I could definitely screenshot it for you. Let me see. Why?